All right, so today is multi-step equations. Make sure that you've done the modules on collecting like terms, 1 and 2 steps. And now we're going to go into multi-step equations, which are going to require us to have a method where we need to get all the variables on one side of the equation, because typically we're going to have a variable term on each side of the equation. So let's go over the steps for solving multi-step equations. The first thing you're always going to want to do is do any expansion you can. So the very first step in multi-step equations is distribution if you can, and we call that expanding. The words are pretty much interchangeable, expanding or distribution. If you need to, the second step is going to be simplifying. Otherwise known as collecting like terms. Collecting like terms, and then the third step is going to be isolating or solving. And that's really the goal of these multi-step equations, is we want to find out what the value of the variable is. So in this first example, there's an x there, there's 3 times x. I want to know what x really is. What does x have to be to make this equation true? So what does x have to be in order for the left side to exactly equal the right side? It can't just be anything. If I put 0 in here, for example, 0 times 3 is 0, plus 2 would be 2 on this side. 0 times 2 would be 0, minus 4 is negative 4. 0 doesn't work. So we're looking for a particular value of x that will make this equation true, that will make the left side equal the right side. And so let's go through this example. We'll do a few examples of progressive difficulty. And in this one, we don't need to do any expansion. So normally our first step is expansion, so distributive property, but there's nothing here to distribute. I don't have any coefficients outside of brackets. This would be an example of something I would have to distribute. This is a multiplication. I don't have that in this case, so I can skip step 1 and go right to step 2. So here I want to simplify and collect like terms. So the first thing I need to do before I can collect the like terms is I need to identify the like terms. So here's a term here, 3x. I need to find all the like terms to 3x. So like terms would have to have the exact same variable with the exact same power or exponent. And in this case, even though it's not written on it, we know that this exponent is really just 1. But in math, we don't like to write ones because we're lazy, so we'll just keep it off. So we do know that that's an x to the power of 1. I'm looking for other terms that have a variable of x to the power of 1, and it's way over here. Now, they're on opposite sides of the equal sign, but that's okay because we're just going to use algebraic manipulation and we're going to make sure that we get them both on the same side. I do have another set of like terms, this positive 2 and this negative 4, because even though to be like terms, the variable has to be the same, not having a variable or being a constant also makes you a like term. So these are like terms and these are like terms. Now I have to decide which side I want the terms with the x to be. It doesn't really matter whether I choose to put them on the left side or whether I choose to put them on the right side, but I have to pick a side. So let's say I'm going to get rid of the 2x on this right side. I'm going to get rid of this one here, and I'm going to do something to the equation to make that happen. Now, I know instinctively what you want to do is you want to say, well, I'm going to move this 2x over here. But that's not really what happens. We don't really move terms from one side to the other. What we do is we eliminate terms from one side or the other. And because our rules in algebra state whatever we do to one side, we have to do to the other, it means that that term will appear on the other side. But let's try to move away from moving things to the other side and switching their sign, because that rule tends to break down, particularly here when things start to get more complicated and we start having to deal with divisions and multiplications. Divisions and multiplications don't move, and so we like to use a system that's more universal, so we're going to do it this way. I want to get rid of the 2x on this side, and I want to put all of these x terms on one side so I can add them together. Well, in order to get rid of a positive 2x, all I need to do is the opposite of adding 2x, because this is really a plus 2x. The opposite of adding 2x is subtracting 2x. But whatever I do to one side, I have to do to the other, so I'm also going to subtract 2x from this side. Now, I'm left with 3x minus 2x plus 2 is equal to 2x minus 2x is just 0, so I'm not going to write the 0 in there. So the only thing left on that right side is a negative 4. All right, great. So I have my two like terms, 3x and minus 2x on one side, but I'm not finished because I haven't collected all my like terms. I still have this positive 2 and this negative 4 way on opposite sides of the equal sign from each other. And they don't want to be far apart, they want to be together because they're like. So I'm going to do the same thing I did with the x terms. I'm going to get rid of either the 2 or the negative 4. Now, before I decide what side I'm going to put them on, let's look at our third step. Our third step is to isolate. And what we're going to do is we're going to get the terms with the x all by themselves on one side. So let's actually simplify this. Let's go 3x minus 2. That's just x plus 2 is equal to negative 4. If I choose to get rid of this 4 and subtract it from this side, then I have the x terms and the constants on the same side. And what's going to happen is I'm going to have to isolate x anyway. So I'm going to have to get x all by itself. So that would add an extra step for me. Instead of doing that, let's just make sure that we get rid of the 2 from this side. So I want to get rid of the 2 from this side because I want to isolate x. I want to get x all by itself on one side. So in order to get rid of a positive 2, we're going to subtract 2 from both sides, because whatever I do to one side, I have to do to the other. So that's going to give me, all that's going to be left on the left side is x. I'm going to write my equal sign right below the one that came before. All that's left here is x, because 2 minus 2 is just 0, and I'm not going to write plus 0, I don't have to. And negative 4 minus 2 is negative 6. That's it. I have x all by itself on one side. And what is x equal to? Well, it equals negative 6. Now, let's check to see if that's the right answer. My original expression was 3x plus 2 is equal to 2x minus 4. Let's substitute in that negative 6. So 3 negative times negative 6 plus 2 is equal to 2 times negative 6 minus 4. All right, 3 times negative 6, it's a negative times a positive, that's going to be a negative. 3 times 6 is 18, so that's negative 18 plus 2 still, because now I'm simplifying, so I got to follow the opposite of, I'm going to follow BEDMAS. Negative 18 plus 2 is equal to 2 times negative 6 is negative 12 minus 4. Let's see. So negative 18 plus 2, so it's negative and it goes more positive, so it's negative 16 is equal to negative 16. Perfect. That works. Great. Let's do another example. Let's do 7 minus 2k is equal to 8 minus 5k. Let's remind myself of my steps. So the first thing is going to be expand, simplify, and then isolate. All right, 7 minus 2k. Let's see. So I can't do anything on this side. I can't simplify this any further. I can't simplify this any further because these are not like terms. So I can't go 7 minus 2k, nor can I go 8 minus 5k. They're not alike. So let's identify all my like terms. There is a like term here. There is a like term over here. So 7 and 8 are both like terms because they're both constants. They do not have variables attached to them. And then I have a like term here, negative 2k. And do I have any other terms with just a k to the power of 1? I do. It's negative 5k over here. Now, I'm going to collect my like terms. I'm going to collect my like terms and isolate at the same time. So I need to decide whether I want the k terms to be on the left or the right. It doesn't actually matter. We put them on the left last time, so let's put them on the right. And to put them on the right, that means I got to get rid of this negative 2k. But I can't just get rid of it, and I can't just pick it up. So let's actually eliminate it from that left side. What's the opposite of subtracting 2k? Well, it's adding 2k. And whatever I do to one side, I have to do to the other. So negative 2k plus 2k, that's just going to give me 0. I'm going to put my equal sign directly below the one that came before. What's left on that left side? 7. And what's left on this right side? I still have that 8. Now, let's do this addition right now. So negative 5k plus 2k. So I'm negative 5 and I'm adding 2. So I'm going 2 more positive. So I'm going to get negative 3k. I'm nearly there. I just need to deal with this 8. So I need to collect those like terms. I need to put them all together before I do anything else. So let's deal with that right now. So I want to get negative 3k all by itself is sort of the goal. I want to get this term by itself. So I'm going to subtract 8 because the opposite of adding 8 is subtracting 8. But whatever I do to one side, I have to do to the other. So let's do this again. So negative sign directly underneath. 7 minus 8 is negative 1. 8 minus 8 gives me 0. I don't have to write that in, and I have a negative 3k. So I've collected all my terms, I've simplified everything I can, and now I'm down to negative 1 on the left side and negative 3k on the right side. But that's weird because that's not what k equals. Negative 1 isn't what k equals. Negative 1 is k times negative 3. So I need to figure out what k is, which means I need to isolate k, which means I need to get it all by itself. Well, what's happening to the k? The k is being multiplied by 3. That's what the coefficient means. When there's a number in front of a variable and there's no space in between, it's really just multiplication. We're just too lazy to write it in. So this is negative 3 times k. What's the opposite of multiplying by negative 3? The opposite of multiplying by negative 3 is dividing by negative 3. And that's true with any case. So if I have 3 times 2 and then I divide it by 2, I always end up with what I started with. Multiplying by a number and dividing by that same number cancel each other out. 3 times 2 is 6, divided by 2 is 3. It's almost like it never really happened. So as long as I'm dividing and multiplying by the same value, and it has to be the same sign too, but as long as I'm multiplying and dividing by the same value, I can get rid of what's going on. So I can isolate that k. So let's do that. Let's divide negative 3k by negative 3. So now I'm multiplying k by negative 3, but I'm also dividing k by negative 3, so that's going to eliminate itself. But whatever I do to one side, I have to do to the other, so I also have to divide negative 1 by negative 3. I'll move my equal sign directly below. Negative 1 divided by negative 3, I'm going to keep this as a fraction, but a negative divided by a negative is a positive, so it's going to be positive 1/3. This is gone. K is equal to 1/3. You could check your answer by going back and plugging it back in for k in the original equation and seeing if it works. All right, let's do a slightly more complicated equation. Let's try this one. And then we'll go into solving equations with brackets. So here I have 0 on one side, and then 14 minus x plus 6x minus 9. So my first step is always to distribute, but of course, or expand. I don't have anything to expand here. We will in the next question. So my next step is to simplify. Put everything together that I can before I isolate. So let's simplify. I have 0 is equal to, let's identify my like terms. I have a 14 here, which is a constant. It's a constant because there's no variable in front of it. Variable means change, constant means not changing. So if there's no variable, it doesn't change. It's always 14, so we call them constants. There's another constant here, and it's negative 9. All right, there's a x to the power of 1 term, and there's also an x to the power of 1 term here. So let's collect our like terms by adding and subtracting. So this is 14 minus 9. So 14 minus 9 is going to give me positive 5. And then negative x plus 6x, that's going to give me positive 5x. Great, so I have 0 is equal to 5 plus 5x. Now I can move on to my last step, which is isolating. So I'm going to isolate by getting the 5x all by itself first, and then I'm going to get the x all by itself. And if you're wondering why we deal with the addition subtraction first, when we isolate, we are doing the opposite of BEDMAS. When we simplify, we use BEDMAS. When we isolate, we use SAMDEM. We're going to deal with subtraction addition first when we're getting something all by itself. We're going to deal with subtraction addition first, then we deal with multiplication and addition, or multiplication and division rather, and then we deal with exponents and brackets in that order. So I'm going to get this 5x term all by itself on one side, which means I got to subtract a 5 from here, because this is positive 5, and the opposite of adding 5 is subtracting 5. But whatever I do to one side, I have to do to the other. So let's move our equal sign down here. 0 minus 5 is negative 5. 5 minus 5 is 0, and all we're left with on this side is 5x. That's not my answer yet, because I want to get x all by itself. I've done the subtraction addition isolating. Now I have to deal with multiplication and division. This is multiplication, even though we don't write it in. The opposite of multiplying by 5 is dividing by 5, but whatever I do to one side, I have to do to the other. Negative 5 divided by 5 is negative 1, and these cancel it to give me 1, and all I'm left with on this side is 1x or x. And again, I could take that answer, I could plug it into here, and I could double check to make sure that the equation stays true. So this would be 14 minus 1 minus negative 1, which is adding 1, so 14 plus 1 is 5. This would be 6 times negative 1, which is a minus 6, would be 9, minus 9 is 0, that works. All right, it's time for solving equations with brackets. Let's just jump right into a harder equation. Okay, let's try C. And in fact, let's write down our steps first. So finally we get to expand. So there's definitely something to expand here. And then we're going to simplify. And then we're going to isolate. So we're just going to follow our distribution rules. If there's a coefficient in front of a bracket, that's really multiplication. Dot represents multiplication. So I'm going to distribute the left side and the right side before I do anything. So I'm just going to write my equal sign right below where it was. And here we go. So 2 times x first, so that's going to give me 2x. And then 2 times negative 3 is going to give me negative 6. Moving on to this right side, negative 3 times x is negative 3x. Negative 3 times 5 is negative 15. And this negative 6 is still hanging around, so let's not forget about him. He just tags on to the end right there. Great, I'm done my expansion. Now I got to simplify. So let's simplify what we can. 2x minus 6, can I simplify these at all? No, I can't. I can't collect these two terms, they're not alike. Is there anything I can simplify on this right side? So let's see, so negative 3, actually I'm just going to write 2x minus 6 because I can't change anything there. Are there any like terms on this right side? There are. In fact, negative 15 and negative 6 are alike because they're both constants. So we're going to end up with negative 3x minus 15 minus 6 is going to give me negative 21. Great. So I've simplified everything I can without now eliminating. So now we're moving on to the isolation phase. So we want to isolate the x terms by themselves by getting them all on one side. So we want all these x terms on one side and all the non-x terms on the other side. So all the constants on the other side. Again, it doesn't matter which side we decide to put the x terms on. I'll put them on the left side. So I want to get rid of this negative 3x. How do I get rid of a negative 3x? Well, I add 3x. And whatever I do to one side, I do to the other. So we end up with 2x plus 3x. I'll write it out before I simplify it this time. Is equal to negative 3x plus 3x is equal to negative 3x plus 3x minus 21. Move this down a little bit. All right, now let's simplify what I can now. So 2x plus 3x, that's going to give me 5x on this side, and that negative 6 is still there, is equal to negative 3x plus 3x, that's just 0, and all I'm left with is negative 21. Great, almost there. I just have this negative 6 in the way of the 5x being by itself, so I'm going to add 6 to both sides, and I'm going to get 5x minus 6 plus 6 is equal to negative 21 plus 6, and I'm going to move my equal sign down. Negative 6 plus 6 is 0. I'm left with 5x on this side, and negative 21 plus 6, that's going to give me negative 15. I have one last step. Let's do it right here. Let's rewrite the equation. I just want to get this x all by itself. And remember, we're following SAMDEB, so we dealt with our subtraction and addition first by making sure that we collected all the like terms on opposite sides. So now I'm left with is this multiplication. I'm going to divide by 5 because that's the opposite of multiplying by 5. I want to get this x by itself. This x is being multiplied by 5, so I'm going to divide it by 5. I'm going to do the opposite operator is what we call it. 5 divided by 5 is just 1, so that's going to leave me 1x on this side. Negative 15 divided by 5 is negative 3. And I can roll all the way back up here. I can put negative 3 in here just to make sure it works. And I can do that solution to double check my answer. And that's it. This is a pretty tough concept, so if you need more examples, please let me know. Definitely message me, or if you need some one-on-one help, or we could schedule that, absolutely. I will give tutorials on Thursday, and then we're going to talk about word problems with multi-step equations tomorrow. Everybody have a good day, and I will talk to you soon.